Today is our first lesson in geometry, and we are going to be going over some geometric terms and notations of some geometric terms so that we can actually go into more discussion about things that we know about geometric shapes, geometric objects, but we need to have an understanding of some definitions. So before we get into what we call defined terms, we're going to actually start with what we call undefined terms. So undefined terms, an undefined term does not have a formal definition, but there is agreement about what it means. So the next couple of terms that we're going to talk about are undefined terms, but there is understanding of what they are. There's just no formal definition for them. Okay, so first is a point. A point names a location, and it has no dimension or size. Points are represented by a dot, and they are named by a capital letter. So for example, here we have a dot and it's labeled with a capital A, and we would call it point A. The next undefined term is a line. So a line is a straight path that has no thickness and extends forever. It has one dimension, and it contains an infinite number of points. Now, generally, when we try to represent lines, they are going to be represented by a straight line with arrows on both ends. Now, how do we name lines? There are a couple of ways to name lines. You can either use 2 points on the line with the symbol above with a line with the 2 arrows right above it, or you can also use a lowercase cursive letter to name a line. So here's an example. Here's this line, and we can call it line L. Notice it's a lowercase cursive L. You can also call it line AB, and to notate that you would write AB with the notation above it, or you can call it BA. The order there does not matter. All right, next we have a plane. A plane is a flat surface that has no thickness and extends forever. So a lot of the times you might imagine this like a sheet of paper, but the only difference is a sheet of paper actually does have some sort of thickness, even though it might be very, very thin. But a plane does not have thickness, and it continues to extend forever. We would say this has 2 dimensions, and planes are generally difficult to represent because they have 2 dimensions. It's usually more difficult to try to draw out. So usually what we do is we indicate a plane by drawing some sort of parallelogram. And that way you can sort of see how you have a flat surface by drawing a parallelogram. But note that that does add thickness, and it does not allow you to represent that extends forever. All right, so how do we name a plane? So just like with lines, there are a couple of ways to name a plane. You can either use the word plane followed by a single capital letter, or you can use 3 points that are on the plane. So here's an example. So we've drawn a plane here using a parallelogram to represent it. And you can call this either plane M, so using a capital letter to name that plane, or we have points A, B, and C, which are all on that plane. So we can call it plane ABC. It doesn't have to be in that order. You could say it's plane ACB, plane BAC, anything like that. Now, a couple of related definitions, now that we've talked about a line and we've talked about a plane. We say that points that lie on the same plane are collinear points. So collinear, so on the same line. So we say those are collinear points. And then points that lie in the same plane we call coplanar points. Okay, so take a look at example 1 here, and we'll just try to name some collinear points, non-collinear points, coplanar points, and non-coplanar points. Now there are going to be a number of different answers here, but just for practice. So collinear points, these are points that lie on the same line. So you have to be able to tell that they are on a specific line. So you could say that Q and P are collinear points. You can say P and T are collinear, S and P are collinear, S and T are collinear. Now, non-collinear points, you would say, for example, S and V are non-collinear points. Coplanar points, so these have to be on the same plane. It looks like we have the plane R that's drawn out here for us. So let's find some points that are all on plane R. So it looks like V, S, P, and T are all coplanar points, but you could say that T and Q are non-coplanar points. Great, now that we've talked about some undefined terms, now we can use those to build up all of our other definitions that we use in geometry. So first, let's start with a line segment. Now, a line segment is the part of a line consisting of 2 points and all the points between them. Now, segments are named by their endpoints with the symbol above. Now, notice how this is different from a line. A line had the arrows on either end, but because a segment is, you can think of it as a truncated part or just a segment of a line, it's only part of a line, we don't have the arrows. So here's an example. We have 2 very clear endpoints. The line segment is just that segment. It does not continue infinitely in both directions. So we would say, well, since one endpoint is A and one endpoint is B, we would either call this line segment AB with the symbol above it, or line segment BA with the symbol above it. Now you want to use the endpoint, so if you had a point in between, you don't want to use that point because then that defines, let's say, some point C that's in the middle there as being one of the endpoints. So with line segments, you have to use the 2 endpoints. Now an endpoint is the point on one end of a segment, as we've seen here, or it could be the starting point of a ray. Okay, well, what's a ray? That's our next part right here. So a ray is a part of a line that starts at an endpoint and extends forever in one direction. So at this point, we've seen a line extends in both directions. A line segment does not extend in either direction, and a ray extends forever in just one direction. All right, a ray is named by its endpoint and one other point on the ray with this symbol above. So you can see here, there's only an arrow on one side, so it only extends on one side. Now, this is important, the order in which you put the letters. The first letter is always going to be the endpoint. So for the example up on top here, the endpoint is A, and then B is on the other side and it extends through B and continues on. So we would use AB and then put the symbol above it. Now in the second one here, the endpoint is at B. So in order to differentiate between the top and the bottom cases, which are different from each other, we would start with the endpoint, so B, and then it goes to A. So we would write this as BA with the symbol above it. All right, next we have what we call opposite rays. Opposite rays are 2 rays that have a common endpoint and form a line. So here's an example. So we have A, C, and B all on this line here. Now if point C lies on line AB, and it's between A and B, which it is, then we would say that CA and CB are opposite rays. So ray CA and ray CB are opposite rays. So they are 2 rays that have a common endpoint, that's C, and they form a line. So it's not just that they share C, but if you were to draw out ray CA and ray CB, you end up with just one straight line. All right, take a look at example 2. Give another name for line segment GH. And then part B, name all rays with endpoint J. which of these rays are opposite rays. All right, for the first one, another name for line segment GH, well, we know we have to use the endpoints, so it's not that we can use J in there, because this is a line segment, but the order in which we give those endpoints does not matter for a line segment. So we could also call this line segment HG. All right, for B, name all rays with endpoint J. Okay, so we have JE, JG, JF, and JH. Those are all rays. Now, which of these rays are opposite rays? So remember that opposite rays, they share the same endpoint, which all of those that we just listed do, but they also have to form a line. So in this case, JE and JF are opposite rays because they form that line EF. And then JG and JH are also opposite rays because they form that line GH. Great. We just have a couple more things to go over. So next we have intersection. So we say that two or more geometric figures intersect if they have one or more points in common. Now, we can have two lines intersecting, and when we have two lines intersecting, they have one point in common. So the intersection of two lines is going to be a point when they're two different lines. Now, if you have two planes intersecting, so remember we represent them with parallelograms, so if I draw two of them here, we can see that the intersection of those two planes is actually a line. So this actually has not just one point in common, but an infinite number of points in common. All those points that are on that line Q are common to both planes. So the intersection of two different planes is a line. All right, the next concept we'll talk about is congruence. So we say that two geometric figures are congruent if they have the same measure. The symbol that we use to indicate congruence, it looks like an equal sign with a little squiggly on top. All right, and now in terms of diagrams, how do you mark that certain segments are congruent to each other? We use what we call tick marks. All right, so here we have line segments AB and CD, and they are congruent to each other. So in a diagram, you would use tick marks, so those red lines there, to indicate congruency. Now, if you had multiple lines that are congruent, like these two lines are congruent, and then there are two separate lines in the same diagram that are congruent to each other, but not to these, then you would just add more tick marks to indicate that those are congruent to each other, but not to these. Now, in terms of notation here, we can say that AB is equal to CD because the length AB is equal to the length of CD. But when we're talking about segments, we want to use the term congruent. So if you have line segment AB, so the notation with the line on top of AB, and line segment CD, we want to say that those are congruent to each other. Now we can also talk about angle measures being congruent to each other, and in those cases, we use what we call arc marks. So here's an example. We have two angles here, and you can see those red lines are arc marks. And again, if you have another angle measure that's equal to another angle measure in the same diagram, but it's not equal to these two angle measures, you would just add another arc mark onto it. So same with tick marks, you would just add more tick marks to indicate another set of congruent lines. For arc marks, you just add another mark to indicate another set of congruent angles. Okay, and then the last thing we're going to talk about, we've talked a lot about different terms, different notations. and we've talked a little bit about some broad general concepts in geometry. Now, the last thing we're going to talk about is what we call postulates. So a postulate is a rule in geometry that is accepted without proof. So here's an example of a postulate. Through any 2 points, there exists exactly one line. Now, generally, this rule is accepted without proof because it is something that we can understand. If you were to imagine 2 points, doesn't matter, any random 2 points existing, you would only be able to draw one line going through those 2 points. And so there's no need for us to prove it, and so we would call this a postulate.